Let's talk about what we've accomplished so far. For me to differentiate this polynomial function, we know how to do it. We take the limit of this difference quotient. Now, in going through this process, as you saw in the past, here's what you get. So if you don't mind me saying, I think that's a lot of work. So I think we're set now for looking at maybe some shortcuts to the differentiation process. So let me dive in and start talking about the shortcuts to differentiating polynomial functions. And while I'm here, I'll talk about differentiating the natural exponential function. Might be a bit theoretical, but I need to create a nice clean list for us so that we can differentiate these kinds of functions much more easily than using our limit of a difference quotient. Let me get started. Let's see what happens if the output of my function is just a constant. Let's see when I determine what its derivative function is going to look like. I might be wasting a little bit of ink here, but in general, this is the only tool I have in my back pocket for generating a derivative function. So let me exploit it. Now, this function says that no matter what the input is, the output's a constant c. So if you've added this rather complex input, it's still going to give you an output that's c. On the right-hand side of the subtraction operation, again, regardless of what the input is, here's the output. Now that gives me this, which looks like it could be a problem. It looks like I've got a 0 over 0 situation. It looks like I have a limit in an indeterminate form, but it's not true because prior to taking the limit, 0 divided by anything that's non-zero is going to be 0. And I don't care if h is actually equal to 0 because I'm taking the limit. So I'm going to treat h as non-zero. So 0 divided by a non-zero number is just 0 itself. However, the limit of a constant is just that constant. So look what I've just accomplished. I have found that to differentiate with respect to x a constant, I simply get that. Oh, by the way, before I finish off, I'm sorry, I should have said something. Doesn't this make complete sense? If you take a peek at the graph of the equation y equals a constant c, it's just a horizontal line. And so the tangent line ever on the horizontal line is horizontal. And therefore, numerically speaking, its slope is indeed going to be equal to 0.